Hi, I am Balasubramaniyam, Assistant Professor, Department of Computer Science, Sengundar Arts and Science College, T.Gode. Here in this video, I am going to discuss about operating system. Here the operating system is an interface between a computer user and the computer hardware. Here the operating system is a software which perform all basic tasks like file management, memory management, process management, handling inputs and outputs, and control peripheral devices such as disk drives and printers. Some popular operating systems are Linux, Unix, Windows, Apple, Mac OS, etc. Here, the operating system performs some basic tasks like file management, memory management, process management, and handling input and output devices, and some controlling peripheral devices such as hard disk and printers. Here, the operating system play a major role from the diagram. It is the interface between the system software and softwares and hardwares. Here, the example of an operating systems are Unix, Mac OS, MS-DOS, Windows, Chicago, etc. In this video, we will learn what are the functions available in the operating system, some services, what are the services that are provided by the operating systems, what are the main uses, kernel uses in the operating system, define system calls, and the structure of the operating systems. First, let's see operating system functions. Here, the operating system perform the following functions like memory management, task or process management, storage management, device or input-output management, kernel or scheduling. Here, first let's take memory management. In memory management is the process of managing a computer memory. Memory are two types, primary memory and secondary memory. Here, the memory portion for programs and softwares is allocated after releasing the memory space. So, here the main memory is called as RAM, and the secondary storage is called hard disk. Here, if the RAM got filled, main memory, it can be swapped out to the process P1. Process P1 is swapped out to the secondary memory. After the RAM get freed, the process P2 is moved to swap into RAM. This is the process going on the main memory and secondary memory. Here, the memory management is important for the operating system involving multitasking concept. So, with the help of multitasking, we can achieve more than one process at a same time. Next, task or process management. Here, the process management is an instant of a program that is being executed. The process consists of number of elements such as identifiers, program counters, memory pointers, and context data, and so on. Here, the process is actually an execution of those instructions. There are two types of process method. One is single process and multitasking process. Single process can execute a single program at the same time. Multitasking means it will be execute more than one process at the same time. So, multitasking method allows the multiple process at a same time. Here, this diagram that represent, if you are going to create a process or going to click on some application, it will be moved to the ready state. Then it will be moved to running state with the help of run function. Then after, if the running is success, after it can be terminated. Otherwise, some critical situation, it can be blocked for particular time. Then after, it can be moved to the ready state and it will be again go to the running state. Otherwise, the block can be blocked, suspended, and returned back. This is the individual process that can be run entirely. Next, task or process management. There are some number of elements. These are the some number of elements, that is identifier, state, priority, program counter, memory pointer, context data, and input output status information and accounting information. Here the identifier is the unique identifier associated with each process. So individual process have unique identification in the type of identifier. Next, state. Here the state is that the state indicate the process in running state or waiting state or block state. Next, priority. Priority level relative to other processes. Next, program counter. Here the program counter that address the next instruction in the program to be executed. Next, memory pointer. Memory pointer includes pointer to the program code and data associated with the processor. Next, context data. There is a data that are present in the register in the processor while the process is executing. Next, input output status information. Here, what are the input that are available from the hard disk or through the keyboard or mouse? What are the output that can be available through the process. Next, accounting information may include the amount of processor, time and clock. So that it indicate time used, time limits, account numbers and so on. Storage management. In storage management, it is a function of an operating system that handle memory allocation of your data. The system consists of different types of memory device, such as primary storage memory is called as RAM, and secondary storage memory is called as hard disk, and cache storage memory. The instructions and the data are placed in the primary storage or cache memory, which is referred by the running program. However, the data is lost when the power supply cut off. So here the secondary memory play a major role. If it is a permanent storage memory, the operating system allocate the storage place when the new files are created, and it can be requested for memory access is scheduling. Next, input output management. Here the input output management, we interact with the machine by providing an information through input output device. For example, if you take an input device, is a keyboard, mouse, these are some input devices. Output devices, display, printer, etc. These management of all device affect throughout the systems. Next, process scheduling. Scheduling is a very important concept in the operating system. It is the process of controlling and prioritizing the messages sent to the process. Here there are three types schedulers available in the operating system: long-term scheduler, short-term scheduler and medium-term scheduler. Here the operating system provides the following services, that are program development. After the development of program, the program can be executed, and with the time of execution it can be accessed through the input devices, and it will be given data through the input devices, and it will be control the access to the files, and also it access the system. Whether the time of access, there can be error detection and the response will be occurred. Some types of errors are occurred like hardware errors and software errors. Next, here the program development. Program development, OS provide a variety of facilities and services. For example, tools, we called as tools, and debuggers to assist the programmers. Assist means we will be help the programmers to create the programs. There are a lot of tools are available in our society nowadays. These tools are helpful to the programmers to create a program with a simple manner. Next, program execution. The number of tasks needed to perform an execution of program. So here we need the creating instructions, and the data must be loaded into the main memory. Then after only the program will be executed. So the other resources may be prepared. So OS handle the scheduling duty for the user. Next, access to the input device. Each input output devices requires its own set of instructions. These instructions are the uniform interface that hides their details so that the programmer can access such as services. Next, control access to the file. There are a lot of control mechanism to access the file to prevent the file mechanism. Next, system access. So system access also resolves some conflicts, how to protect the resources and the data through the system access. Error detection and response. Here the error can be occurred while running of the system. There are two types of error will be occurred. One is hardware error and software error. Hardware error maybe some examples are like memory errors, device failures, malfunctions, etc. Next, software errors example arithmetic overflow error, access forbidden error, memory location error, like this. These all are some software errors occurred. Next, kernel. Kernel is one of the part of an operating system and it is the core component of an operating system. It is also called as a program and it is a part of operating system. It converts the user command into machine language, high level language to machine language. So the kernel play a interface between the applications and the CPU memories and devices. What are the difference between operating systems and kernel? Here the operating system is a system software and it is the system software and it is a part of an operating system. Kernel is a part of an operating system. An operating system provides the interface between the user and the hardware. Here the kernel provides the interface between the application and the hardware. It is also provide protection and security. The kernel main purpose is memory management, disk management, process management and task management. Here all system needs the operating system to run. Here all operating system needs kernel to run. So here the kernel is very, very essential for all systems, all operating systems to execute or run the program. Next is system call. System call is a interface between a process and the OS. It is usually available in the assembly language instruction. Nowadays, the system allows the system call directly from the high level language program like C, C++, Java, BCPL and Kernel. Next is system call. System call are grouped into 5 major categories. One is process control, second one file management, third one device management and fourth one information maintenance and finally communication. Here the system call, there are different types of system call. System call in process control, there are 3 different system calls are called creating a process, exist process, wait for signal object. And in file management, there are 4 different system calls are allowed. One is to create a file, another one is read a file, another one is write a file, another one is close handle. Next one types of system call is called device management. In the device management, there are 3 types of system calls are called. Example, set console mode, read console and write console. Next, the information maintenance. In the system call, the information maintenance, there are 3 types of system calls are called at the time of execution of program. Get current process ID, set timer and sleep. And finally the communication. Through the network communication, there are 3 different system calls are allowed. One is creating pipe, create file mapping and map view of file. Next let's see the structure of operating system. Here the operating system structures have 5 designs. They are monolithic system, layered system, virtual machine, exokernel and client server system. In monolithic system, The entire operating system works in the kernel space in the monolithic system. So, to increase the size of the kernel as well as the operating system, here the kernel play a major role. Kernel mode. In the kernel mode we have virtual file system, interprocess communication, scheduler, virtual memory, device drivers and dispatcher. So, in the monolithic system, the kernel provides the various services such as memory management, file management, process scheduling using the function call. This makes the execution of an operating system quite fast, as well as the services are implemented under the same address space. Advantages of monolithic kernel. Some of the advantages are, in the execution of the monolithic kernel is somewhat faster. In the memory management to fetch the information, the file management to access the file, in process scheduling, schedule process speedily under the same address space. In monolithic system, there are some disadvantages. Here, if any services fails in the monolithic kernel, the failure of entire system. So, if the entire system will be failed, the entire data will be got lost. Next. In layered operating system, we are going to separate the various layers. Each layers have some different functionalities. So, the operating system split into the various layers in the layered operating system, and each of the layered has different functionalities. These types of operating system was created as to improve the comparison of monolithic system. All the layers here we can be defined separately and interact with each other as required. To create and maintain and update the system if we done in the form of layers. Each of the layer in the operating system can only interact with the layers that are above and below. From the diagram we will be learn, for example, in the layer 1 it will be separated by hardware, in layer 2 CPU scheduling, in layer 3 memory management, in layer 4 process management, in layer 5 input output buffer, in layer 6 user program. So we can be separate different layer. Through this layer, if any one layer will be got failure, with the help of remaining another 5 layers, we will be easily executed. Next, virtual machines. In operating system structure, virtual machine is play a major role. By using a CPU scheduling and virtual memory techniques, an operating system can create a multiple process and it execute on its own process with own virtual memory. Each process is provided a virtual copy of computer. So the resources of the computer are shared to create the virtual machine. So non-virtual machine, the first diagram that represent non-virtual machine, the second diagram that represent virtual machine. So each process, the individual kernel can be represented with and it will be executed. So this is the main advantage of the virtual machine. Next, exokernel. Exokernel is the operating system developed by MIT parallelly. The operating system generally present hardware resource to the application through high-level abstractions such as virtual file system. In this diagram, there are a lot of libraries that can be make some copy, and it can be without kernel representation. We will be directly interact with the hardware to execute the program. The program can communicate with the hardware much more directly. So this is some advantages of exokernel in the operating system. Next, finally, let's see the client server model. Here the client server model play a major role in the operating system in the user process to request a service and such, reading a block of file or user process send the request to the server process, etc. Here the client send the request to the server, but the here server, after receiving the request from the client, send the response to the client, what they will be expected. So this is the diagram that represents the client server model. Here the machine 1 is the client, machine 2 is the server, file server. Here the machine 1 will request some information to the server through the kernel. The machine 2 it can be receive the information. After it received, it will be response to the client. This is the message from the client to the server. Here there is a network available for transferring a request and response. So friends, this is the operating system with some basic concept for your reference. Thank you.